Welcome back to SAT Math Question of the Day. Here's our question of the day. Please read it, pause the video, come back to it. And today's Throwback Thursday, so you have to know what's done with this. We're going to go back to a question from 25 years ago. Okay. A study was conducted on an elementary school's extracurricular programs. The study divided the students into two groups, those who attended after-school electives and those who did not. Not random. The results of the study showed that students who attended the after-school electives were more likely to attend summer camp than students who did not attend the electives. Based on the information provided, which of the following is an appropriate conclusion? The operative word here is the appropriate or best conclusion based on the information provided. So it's a judgment call. And usually with these things, there are two answers you could just throw out and two answers that are little subtle. So let's see if it works like that. Attending after-school activities is a requirement for attending. Come on. No. After-school elective attendance is the strongest predictor of whether student, not likely, but let's not throw it out yet. There's a positive association between after-school's electives attendance and summer camp attendance. That's going up in the likelihood. Yeah, you're right. Yes, that's already saying B is out of here. But C looks pretty good. So this looks good, but we have to read on because we need the best conclusion. Okay. If a student stops attending, what? Okay, these two are out of here. Completely out of here. And this is not likely. There's something wrong here. This choice is better than this choice. A lot better. Because nothing tells you in the information provided that it is the strongest. Right. There is no evidence. There's no evidence in the little thing above. So it looks pretty obvious that choice C is the best of the four.
Okay. What does strongest mean?
It means that is the predominant cause. It means
no.
No? Okay, what does it mean? I give up.
Can you read what I wrote?
Yeah. This means there is no stronger... What? This means there is no...
Predictor. There is no stronger.
Okay. Fine. There is no stronger predictor. Okay. There's nothing discussed.
Now, that's what strongest means. It doesn't mean the predominant one. It doesn't mean anything else. It particularly means that there might be other predictors, right?
Yeah.
But this one is of all of them the strongest one. That means all of them are weaker.
Okay.
Yeah.
But there's not even.
It doesn't mean it's the most noticeable.
Right.
It's the most effective, and there's no, and as you said, there's no information that indicates how strong. There's no indicator that indicates that there are other predictors. Right. That there's no information that rules out other predictors being stronger.
Right. Like maybe how many friends someone has, or how their attendance in school, or anything, or any of this stuff. Yeah. So it looks like choice C is the best choice. Okay. So I guess we can move on, right? There's really nothing. These questions, there are no numbers in here. Obviously, a calculator is.
It's a question about careful. It's a precise meaning of price meaning of statements in English.
Right, but having to do with
some logic.
Statistics. This is also in the category of statistics. I know years ago, we're going to go back to a test, from years ago, and a question like this was never on here. This is a fairly new topic that was added. Okay, so let's see how they do it. How they go through it. So let's see. Okay, let's see how we answered the question. So, of course, there's only words in the answer. For a study,
Yeah.
to be able to support conclusions about cause and effect, it must have a well-defined population. Boy, they're getting real technical. A representative sample of the population, a random assignment. So they're using all these words that one
Yeah.
should know the definitions of because they will come up on other tests, other questions. Okay, according to the information, study participants for elementary school, a well-defined population. Oh, good. So they're going through the way you have to think about these things. All the students were included in the study, so it's representative. The participants were not randomly assigned. That's right. Okay. Because the study does not have random assignment, we cannot make conclusions about the cause of effects of the population studied. While students who attended the electives were more likely to attend, we don't know about the other factors driving their summer attendance. For example, students attending both the after-school electives and summer camp may have had parents who work late and all through the summer. Aha! But they were never told that. So, the following is an appropriate conclusion, and that's it. So
what do they say about number 4?
What about number 4? Oh, you mean why number 4 is wrong?
Oh, 1, 2, 3, yeah.
Let's see. Okay, but let's see why number 2, which was the only one that was anywhere competition to the answer. The study exam, we're reading the second one. The student examined only the relationship between after-school attendance and summer camp. Since no other activities were included in the study, we can't compare it. So it's exactly
we cannot compare. Yeah. We cannot compare with other predictors.
Right. Yeah.
So there are none other. Given.
Right. Yeah. Okay. The only comment here is that they are bringing in vocabulary that is going to be useful, likely to be useful on future questions. So just study this. Do, as we're going to say, go to Khan Academy. If you're weak on this, like I know I was because I never did this stuff in school, go through all the questions they have in this category.
Positive.
Go through all the questions in this category and get strong on the vocabulary here. What is a population? What is a representative sample? What is random assignment? It's really important to understand those terms. We're not going to go through them now, but if you're weak on this and you're not sure what these things are and how they are defined in statistics, please go over these questions from Khan and other questions. Okay, so welcome to Thursday, Throwback Thursday, where we go back to a book that looks sort of ancient, very, very old school. Look at this thing.
Real SATs.
Yeah, from like
real
30
cats.
years ago. Back then, the tests were more, they claimed not intelligence tests, but they certainly were not exclusively tested exactly what you learned in school. They had questions with quirks in them. So let's look at one. Oops, nope, there it is. That's what we want. Okay, looks a little intimidating. Okay, so unusually, and then by the way, they also labeled questions as difficulty level, and we're only doing the difficulty of 5, the highest difficulty level. Anyway, without any further ado, try it, pause the video, come back, and we'll do it. Okay, if n is greater than 0, and you have this crazy polynomial, this actually doesn't look that bad. For all values of x, what is the value of k minus n? Well, my first nose tells me to, these are perfect squares. Oh, pattern. Let me annotate and zoom. These are perfect squares, so maybe this is a perfect square trinomial. Give it a shot. Right? Why not? See, this is a perfect square, and this is a perfect square, so give it a shot. Maybe it's this. It is this. Look, it looks good. So k would be the 18. K with 3 times 6 is 8. This thing is 9n squared plus 18n plus 18n plus 36. So isn't this 9n squared plus 36n plus 36? So k would be 36. And n would be 6.
And
n would be 6.
No, not n squared. N squared. equals 6 squared. Yeah,
And
right.
then n is 6, so the
Yeah,
answer will be
yeah,
30.
yeah, yeah. Yeah, what I did was look at the 36
Right?
and look at the n.
Yeah.
And if you multiply this out, you're going to get blah, blah, blah times x squared plus some blah, blah, blah times x plus n squared. And that equals blah, blah, blah x squared plus blah, blah, blah x plus 36. So n squared equals 36.
Mm.
And n is positive. So n has to be 36. So n is 6.
Yeah, and it's
And what's
36.
k? Same reason. When this is multiplied out, we get, if you multiply, FOIL is what they say, 3x plus n times 3x plus n. This term comes from multiplying the 3x and the n twice.
Right.
And adding them.
Yeah.
So this is, what is it? 3 times, yes, it's 3 times x times n. And this is also, 3xn. So that gives you 6xn.
Right.
So 6n. So 6xn. What do we call it? 6x. Yeah, 6x. Where are we?
N,
3xn, right?
Yeah.
Equals
6K.
kx.
Right.
Right? So k equals 6n.
Right. Right. K equals 6n, and n is 6, so k is 36.
Yeah.
That in these polynomials, looking for the special cases is very, very helpful. One special case that the SAT and other teachers are obsessed with is the difference of perfect squares. This comes up on almost every test: x plus 7, x minus 7, and then this thing, the perfect square trinomial, where you have a 3 terms, and the leading term is a perfect square, and the last term is a perfect square. Give it a shot. Give it a shot and see if it's perfect square. And sometimes there's a plus sign, and there's always a plus sign here, and sometimes this is a plus or a negative. This could be a plus or a negative.
What if it's a negative?
If it's a negative, then it would be 3n minus 6 squared.
Yes.
Is 9n squared minus 36n plus 36. So look for this pattern when you have three terms in a polynomial. If the first term and the last term are perfect squares, look for this thing called a perfect square trinomial.
The clue is given right away.
Yes, right away.
They tell you.
Yeah.
They tell you. That the form on the left is the square of a
binomial.
A linear binomial, a binomial with an x term and a constant term.
Yeah, 2 terms. Yeah, no, an x term and a constant term.
An x term and a constant term. Yeah.
Now, just to make sure that nobody goes overboard on this, if you have 9x squared plus 17x plus 36, here you certainly have a perfect square here and a perfect square here, but this is not a perfect square trinomial. Right. So just because you have it, it's not guaranteed. If you had to do this, then you go to the quadratic formula.
Well, the middle term has to be. The middle term has to be 2 times.
Right.
The square root of the x squared term,
right,
times the square root of the constant term.
But I don't like to memorize things. So
don't memorize things.
What I would do is I would look at this and say, well, maybe this is a perfect trinomial.
No,
let's give it a shot.
I didn't even think. I I didn't even think about that this was a perfect square. What I saw was it's an expanded out polynomial
Yeah.
equals a factored polynomial.
Right.
And what I did was multiply out the factored polynomial
Right.
and observe that
Yeah.
that when you apply what they call FOIL,
Yeah.
that you get the middle term by
Yeah. So
multiplying the first and the last
we
of
did that
the
already.
and
We
the
did
and the
that
last
already.
of the first
Yeah.
and add them. By seeing that it's a square, the first and the last are the same as the last and the first.
Right. Right.
So you just do it once and
Yeah.
multiply and take twice.
Yeah. Yeah. So let me just okay, but let me get back to what I was saying before here. Just because you have a perfect square here and a perfect square here doesn't mean that this thing is a perfect square trinomial.
Yeah.
Seth brought in this thing about the 2 times that, whatever. Just take a chance and write it as 3n plus 6 and multiply it out. And if you don't get a 17, then the game is
well,
lost.
there's no chance here, is because they just tell you it.
No. I'm not talking about this problem. I'm talking about other problems. So I'm just not talking about this problem specifically, but here what the other what Seth is saying, which is which if you don't notice, it's a perfect square trinomial. It's 6xn plus n squared, and then you just match terms. And this is a very, very, very important idea. You match terms. Okay, that's the blue that has to match. The yellows have to match. Oops, yellow. Come on, yellow. Yellows have to match. And then the greens have to match. Right? And the greens tell you that n is 6. And then the yellows tell you that 6x is equal 6n is equal to k, because n is 6, k is 36, and then you go from there. And this pattern, this matching of things is really, really an important idea. It also comes up with complex numbers when you have 3 plus 7i plus equals, I don't know, is equal to k plus mi, right? Okay, k is 3 and m is 7. People, sometimes complex numbers do come up. It's the same idea. You match coefficients to the like terms. Big important idea. Anyway, I think we probably got this right. E. Wait. No. D. The answer is D, so that's good. And believe it or not, this was difficulty level 5, which is sort of surprising. You would, because it's classic matching like terms. So I'm not sure why it's difficulty level 5, but it was back then. So, okay. Any other thoughts?
No.
Okay. So I hope people enjoyed Throwback Thursday. I'm Joel. I have a PhD in mechanical engineering from Columbia. My brother Seth has a PhD in mathematics from MIT. He's been a professor at SUNY Albany for many years in computer science. He's now retired. He's a professor emeritus. And we are here to offer different approaches on how to do SAT math questions. We very often come from different approaches with different people, even though we're brothers. And the one approach we do certainly share is going to Khan Academy. And, oh, wow, he lost it. Anyway, going to Khan Academy because Khan Academy offers a lot of practice that's sanctioned by the SAT people. They basically tell you what's on the test. Post-2016, they changed the SAT to really reflect what you learn in school more than anything else. And Khan Academy is a great way because they tell you basically what's on the test. And after you're done practicing on Khan on their practice course, go to the actual SAT website and practice on as many previous SAT questions as possible. So I guess that's it for today, right?
That's it.
That's it. Please give us comments. We like comments. We take them very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com, and we'd be more than happy to do them when we meet. Okay, everyone, have a great day.